Okay, so here we are with part two, okay, of our multi-part review. So we have calculated a confidence interval, okay, based upon a sample of n equals 100, and now we want to get a margin of error only 1/5 as large. So we need a new sample with n at least. So this is just like problem number one in the first video. If you look back at that, the margin of error is calculated by z star times the standard deviation, which means that you can use z star times the square root of p 1 minus p all over n. And so this means that with our given, I chose a nice z-score of 2, and I chose a nice p-score of 0.5. Right, so that makes both values 0.5, all divided by the 200 right there, okay? And when you do that, let me just go ahead and take 2 times the square root of 0.5 times 0.5, right, divided by 200, and I'm going to get 0.071. So I'm over here, and I've got 0.0707, right? So now we need something that's 1/5 as large. So I'm going to take that value and multiply it by 1/5. And so I'm going to take 1 divided by 5 and multiply it by 0.0707. And I'm going to get 0.1414, right? So I want you to keep this number in mind. Right, so now I come over here and I need 0.01414, right? Now look, if I need a smaller margin of error, what we saw last time is I need a bigger sample. So I'm looking at probably either 1,000 or 5,000 to get cranked down to this small of a number right here. So the first one I'm going to put in is the 5,000. I go to my handy dandy calculator, and I put in my original z-score of 2. I put in my 0.5 times 0.5 divided by 1, 2, 3, and I hit enter. And look, there's my 1414. So those numbers are exactly the same. So A must be my correct answer there. All right, so that makes me happy. All right, so that's 2 of those. A certain population is strongly skewed to the right. So as I draw a picture of this, sorry about that, it's going to be not an even tail, but it's going to be skewed out to the right. We want to estimate its mean. Okay, so I'm looking for the center here. So we will collect a sample, which would be true if we used a larger sample rather than a smaller one. So I'm comparing a large N versus a small N. Okay, so the distribution of our sample data will be closer to normal. Well, wait a minute, okay? If you take more data, you're going to get something that approximates the skewness of what you've got. So it's not going to be closer to normal with a larger N. It's going to be closer to the skewed to the right that we see, okay? Now, the other thing is the variability of the sample means will be greater. As N gets bigger, the margin of error gets smaller, all right, not bigger. So the means won't be greater, they'll be smaller. So 3 can't be right. The sampling model of the sample means will be closer to normal, right? So as I take more and more samples of size n, the central limit theorem says I'm going to get closer and closer to this mean value right here with a sampling distribution that is about normal. Okay, and so 2 is the only answer, and so that's going to give us A. All right, so now we're going to scroll to 6, and as you look at 6, this is 2 different samples that we're comparing with 2 different P's. We didn't do anything like this in class, so this is a problem for another day. Sorry that that popped up. All right, so now on to 7. Okay, which is true about a 95% confidence interval based on a given sample? Well, hopefully I made it really clear in class that p hat is in the center, and I go off to the left with p hat minus my margin of error, right? And I go up with p hat plus my margin of error, and I'm looking for p. I'm going to be 95% confident that p is in this interval right here. So if I look, the interval contains 95% of the population. I don't even know what this means. 95% of the data? I don't think 95% of the data is in here. That's ridiculous. That's not what we're talking about. Okay? The results from 95% of all of the samples will lie in the interval. All right. So while this may be true, all of the samples is not what I'm centered on. What I'm centered on is p hat, and what I'm looking for is p. Okay, not all other samples. So that's not going to be it. The interval is narrower than a 98% confidence interval would be. Okay, now wait a minute. If I want to be more confident, I need a larger interval. Okay, so 98% confident is going to have a larger interval than a 95% confident. So yeah, the interval is narrower than if it was 98. So the answer must be A, only 3. All right, so that makes us happy. All right, so now let's look at 8. A truck company wants on-time delivery for 98% of its parts they order for the metal manufacturing. They've been ordering from Hudson Manufacturing but will switch to the new, cheaper manufacturer unless there is evidence that this new manufacturer cannot meet. I think that's the big idea right there. Cannot meet its 98% on-time goal. So the idea is P is going to be 0.98 and cannot meet is going to be less than 9.8. So the null hypothesis should be this, no change. The alternative hypothesis should be this, I'm going to be less than 98%. Because as long as they're at 98%, they're cool, okay? But if they're less than 98%, this isn't good. And so if you look, 8 is A, all right? Now, certainly it can't be D, because that's a change in the null hypothesis. Certainly it can't be E, because that's a change in the null hypothesis. Here, not equal to 98 means it could go down, so it's not going to be B, okay? So really you're just left with A and C. And here is, we're assuming that the trucking company is going to do better than the other company. Here we're assuming that it cannot do better than the other trucking company, and that goes with the verbiage of cannot meet. So we are going to have A as our answer here. Okay? So now we're going to do a formal